Hello students, welcome to K Tutorials. In our last video, we have been discussing the division algorithm method and we did one numerical related to that method. So today we will continue with the numerical and today we shall discuss some problems and I guess you will get more insight into this method, okay? So let's begin. So here is the question. It says that so that the cube of an integer can be expressed in the form 9k, 9k plus 1 or 9k plus 8, okay? So this we need to show by division algorithm method, okay? So for this, so let us first consider that let a be an integer. Let a be an integer and we will carry out operation over this integer, okay, which is the cube operation, and we need to prove that these statements are true, okay? So I guess you remember from the previous class, so what is a division algorithm? What is a division algorithm? What was the expression for it? It was that if a is an integer and if it is divided by, I say, b, then it can be expressed, if a is divided by b, then it can be expressed as a is equal to b into q plus r, okay? If we divide this term a, if a is an integer, if we divide it by any other integer, say b, then we will get a quotient, okay? And along with it, if a is not completely divisible by b, then we will get an integer. We will get a remainder, okay? And if a is completely divisible by b, then the remainder is 0, okay? So this was the expression, okay? So in proving this statement also, we will consider two values. We will consider a be an integer and we will consider some value for b, okay? So how we will consider? We will use the manipulation method and we will manipulate its value, okay? So as we are asked, look at this statement, we are asked to cube the integer, right? If we cube this expression, then this b term will also be cubed, right? This b term will also be cubed. So what should we take such that, what should we consider the value of b such that we get the 9k plus 1 or 9k plus 8, like this time, okay? So it can be interpreted as that if we take, let us suppose that b is equal to 3. If you take b equal to 3, then if you cube it, 3 cube is equal to 27, right? So 27 can be expressed as 9 into 3. Yes, so yes, we can take the b value as 3, okay? If we take the b value as 3, then if we cube it, you can express it in this form, okay? So by the method of first considering a to be an integer, and then by the method of division algorithm, we considered a and b they both belong to an integer, and we considered the value of b to be 3, okay? Value of b is 3. Look, here we have not considered the value of a is 3. It is b is equal to 3, okay? B is equal to 3. We have only considered the value of b to be 3, and both a and b belongs to an integer. That is the case, okay? So there exist, write down, there exist. So if this is true, then there you will find, if you divide a by b, that is if you divide a by 3, then you will find a quotient, and if it is not completely divisible, you will find a remainder, right? So you can write that there exist two unique integers. What is the integers? Q, let it be q, and r, such that this statement of division algorithm is true. That is, when you divide this a by b, you will get a quotient and a remainder. So what is the value of b here? It is 3 cube, right? It is 3, and what you have got the quotient, you have considered quotient to be q, and plus the remainder, okay? So plus the remainder. So you can express it in this form, okay? Now if you have considered this to be true according to division algorithm theorem, then what should be the restriction for r? Then there should be some restrictions for r, no, as per the division algorithm theorem. So the restriction of r was that it must be greater than or equal to 0, but it is always less than b. So what is the value of b here? It is, the value of b here is 3. So the restrictions for r will be r is greater than or equal to 0, but it is less than b, that is 3. It is less than 3, okay? So these are the restrictions for r, and from here you will get the value of r to be, r can be 0, yes, it is greater than or equal to 0, so it can be 0. What is the next? R is an integer, right? Where r is an integer, unique integer, so we have considered r to be an integer. So what is the next integer to 0? It is 1, yes? So one lies within this range. Yes, one lies within this range. What is the next integer? 2. Does 2 lie within this range? Yes, it lies within 0 and 3, right? So 2, we can consider 2. Can we consider the value of r to be 3? No, we cannot consider, right? R is always less than b. Okay, the value of b we have considered here is 3, so we cannot take the value of r to be 3. So these are the possible values of r. So we have got the possible values of r. So now we will use it one by one and prove these statements. Okay, so for r is equal to first 0, if we consider the value of r to be 0, then what will be the expression for a? What will be the expression for a? It will be 3 into q plus 0, which is nothing but 3q. Okay, so now we have got the expression of a as 3q. Okay, that is if there is no remainder, that is if the remainder is 0, then we can say that 3 divides a completely. Okay, and for when you divide, you receive the quotient to be q. Okay, so this is the expression, and what we will do next, you will cube it so that we can express it in this form. Okay, so just write cubing both sides. So a cube equal to 3q whole cube. Yes, so a cube equal to 3 cube is 3 cube value, as these are product terms, so we can distribute the power. Yes, 3 cube is 27 and q cube. Okay, so we have got this. You can express it as 9 into 3 q cube. Yes, you can express 27 as 9 into 3, which is 27, which is nothing but 27. So you can express it like this. And we know that 3 is an integer, and as q is an integer, as we have considered this q to be an unique integer, right? As q is an integer, so this whole term 3q cube will also be an integer. Yes, we can write that. You can write this, you can replace it by some other integer, say 9 into say k. Okay, you can express it as k, where you write down where k is equal to 3q cube. Okay, where k is equal to 3q cube, and this term is nothing but an integer. Why it is an integer? Because 3 is an integer, and as we have considered q to be an integer, q is an unique integer, right? So this whole term q cube will also be an integer, so 3 into q cube will also be an integer. So thus we have replaced it by some constant quantity, say k, where k is equal to this and k belongs to an integer. Okay, so you can write this. So 9, you can simplify it as like this, 9k. Okay, so now we have seen that we have expressed cube of an integer. A was an integer, so we have expressed its cube as this 9k. Okay, in the form of 9k. So now further we will consider the other conditions, that r is equal to 1, r is equal to 2. So considering this, we will prove these two statements. Okay, so now for r is equal to 1. Okay, so what was the expression? It was a is equal to 3q plus r, isn't it? So this was the expression. So if we substitute r is equal to 1 in this expression, so what you will get? You will get a is equal to 3q plus 1. So this will be the expression. Okay, so now again cubing both sides, 3q plus 1 whole cube, write down cubing both sides. Okay, so you need to cube both sides so that the equality is maintained, right? So this is the expression. So just simplify it. Okay, a cube is equal to, now I guess you know the a plus b whole cube formula, or if you don't know, I will write it here, a plus b whole cube. What is the a plus b whole cube formula? It is nothing but a cube plus b cube plus 3 into ab into a plus b. Yes, is the formula for a plus b whole cube. So we will just break this term. You will consider 3q as a and 1 as b, and using this you can break this expression into this term for further simplification. Okay, so just break it. Well, first it is a cube plus then b term is here b cube, right, plus 3 into ab, right, a into b. So 3q into 1. A term is 3q, b term is 1, so it is a into b. Okay, and what is the remainder? Into a plus b. So what was the a term? 3q plus b, that is 1. Okay, so this is the required expression. Okay, So just simplify it more. 3 cube, you know the value of 3 cube, it is 27. 27 cube plus 1. 1 cube is 1, right? 1 into 1 into 1, it is 1. Sorry, plus now 3 into 3. 3 into 3 cube, it is 3 into 3 is 9. It is 9 cube. 9 cube into 1, it is 9 cube. Okay, 9 cube. In the bracket, you can write 3 cube plus 1. Okay, so you have got this. Okay, we can simplify it more. Yes. So what you can add more? Okay, so let's break this term. Okay, let's break this term. So let's see what you will get by breaking this term. Okay, so if you break this term, you will get 9 into 3. You can express 27 as 9 into 3. 9 into 3. 9 into 3 q cube. Yes. So I will bring this term in the middle. 9 cube. 3 cube plus 1. Okay, plus, and this 1 term is I will express at last. Okay, so I guess you can take common 9q, right? You can take common 9. Better you take common 9 from both the terms. Okay, 9, take common 9. So 9, if you take common 9, what you will be left out with this term? So 3q cube. Okay, plus and here you are left out with 9. You have taken 9 common, so you are left out with q into 3q plus 1. So this is the term you are left out with in the bracket. Okay, so simplify it more. 9 3q cube plus 3 q into 3q, it is 3q square plus q. Okay, plus 1. So this is the expression. And if you notice that in this expression 3 is an integer, q is an integer, and their summation will also be an integer. So you can express it in the form of another integer, say k. So you can express replace it by k plus 1. So write down, you need to write down here that where k is equal to 3 cube plus 3q square plus 9. Yes, so it is not 9, it's q, plus q belongs to an integer. Okay, so you have to write down this. Okay, so yes, this is the term I guess you were about to prove, right? Yes, so it is 9k plus 1. Yes, so you have expressed the cube of an integer. A was an integer, its cube in the form of 9k plus 1. So this was what you were required to prove. So, and at last the condition which were left out with is r is equal to 2, right? Can r be 3? No, it cannot be 3, right? Because we have considered the b to be equal to 3 and r cannot be greater than the or equal to the b term. Okay, so we are only now left out with the last term where r is equal to 2. Then we will prove the second condition. Okay, so now we are only left out with r is equal to 2. So if r is equal to 2, then what will be the expression for a? The expression for a will be 3q plus r, right? So what is the value of r here? 2. So we will use 2. Okay, what is the expression for a? The expression for a was 3q plus r, right? So we have just substituted the value of r here. Okay, so this is the required expression for a. Now again the same procedure, just cube this. Okay, a cube equal to 3q plus 2 whole cube. Okay, so I discussed the formula for a plus b whole cube in the last slide. Okay, we will now again use that formula. A cube is equal to a cube. First, what is the value of a here? 3q, right? So it is 3q whole cube plus then b cube, right? What is the value of b here? 2, right? So 2 cube plus then 3 into ab, right? So 3 into, what is the value of a? 3q. What is the value into b? What is the value of b? It is 2, right? Then a plus b. So a plus b is nothing but this is 3q plus 2, right? So by using the a plus b whole cube formula, we have written this expression, and just we need to just simplify it more so that we can get the required result. So 3 cube is 27 cube plus it is 2 cube is 8, right? Plus again 3 into 3 9, and 9 into 2 18. 18 cube, it is 3 cube plus 2, it is 2. Okay, it's 2. Okay, so for further simplification, we will bring this term in the middle. So 27 q cube plus 18 cube 3q plus 2 plus, and we are left out with this term, right, plus 8. Okay, so from here you can take 9 common. Okay, 9 common. If you take 9 common, so what you are left out with in this term? So 9 into 3 27, right? So 9 into 3 27, 9 into 3 27, and q cube. So just multiply it, you will get the same term, right? 9 into 3 is 27, 27 cube. Yes, and in this term plus it is 9 into 2 18, right? So you are left out with 2 cube 3 cube plus 2. So if you multiply it again, you will get the same term. 9 into 2, it's 18 cube 3 cube plus 2, right? So by taking 9 common from these two terms, you got that 9 into 3, it's 27 cube, right? Then 9 into 2, it's 18 cube into 3 cube plus 2, then plus this whole term plus 8. Okay, so we simplified the term inside the bracket more. We got the 3q cube plus 2 into 3, it's 6q, there's 2q, right? So q square plus 2 into 2, it's 4q. Okay, so this is the term we got. Now we can replace this term by another integer, say k. Okay, is this term an integer? Yes. Will this term give some summation will be an integer? Yes, it will be an integer, because 3 is an integer, 6 is an integer, 4 is an integer, and as q is an integer, cube will be an integer, q square will be an integer. Yes, and the summation of the whole term will be an integer. So we can replace it by another integer, say k. Okay, plus 8. Where, write down, where k is equal to 3q cube plus 6q square plus 4q belongs to an integer. Okay, belongs to an integer is that. For q belongs to an integer, because q is an integer, right? So considering q to be an integer, this whole term will be an integer. Okay, so 9k plus 8. So we have expressed the cube of an integer as 9k plus 8. So we were to prove that the cube of an integer can be expressed as 9k or 9k plus 1 or 9k plus 8. At first we saw that the cube of an integer can be expressed in the form of what? A 9k. Okay, 9k. Then we showed that the cube of an integer can be expressed in the form of 9k plus 1. Okay, and at last we showed that this the cube of an integer can be expressed as 9k plus 1. Okay, so the required statement is so true. Okay, by the method of division algorithm. Okay, so now we will consider another problem. So here this question reads so that the difference of a number and its square is always an even number. So if we consider that a number to be any integer, say a, then according to question we need to prove that a square minus a is always an even number. So I guess you remember the condition for an even number. What is the condition for an even number? It was any even number can be every even integer can be expressed in the form of 2q, right? It can be expressed in the form of 2q. And what was the condition for odd integer? It was any odd integer can be expressed as 2q plus 1. For odd integers it was 2q plus 1. So we discussed about this in our previous video, right? So let us proceed likewise as we did in the previous question. So we will at first consider that let a belongs to an integer. Okay, let a belongs to an integer. So by division algorithm, okay, so we have considered a belongs to an integer by division algorithm, given that a and now we need to consider what is the statement for division algorithm. It was what? It was a equal to bq plus r, right? This was the statement. So you need to consider a to be divided by b. Okay, so you need to take some value of b so that you can prove this statement. So what you will take now, the value of b. We are dealing with even numbers, right? We are dealing with even numbers, so we'll consider an even value. And as we are asked to do the square also, okay, so let us take method 2. Okay, b equal to 2. So given that a and b is equal to say 2 belongs to an integer, if this is so, given that this belongs to an integer, then if this is so, then there exist two unique integers q and r. Okay, there exist two unique integers q and r, where q comma r belongs to integer. Okay, they also belongs to an integer. Then if this is so, then we can write that a is equal to what we have considered the value of b. If we have considered it 2, then 2 into the quotient q plus the remainder. So this is the required statement. Okay, so as you have considered the value of b to be 2, b is equal to 2, as you have considered the value of b as 2, then what should be the restrictions for r? Then the restriction for r is greater than or equal to 0, is greater than or equal to 0, and it is always less than b, right? It is always less than b. And what is the value of b here? We have considered the value of b to be 2, so it is always less than 2 for this case. Okay, so considering this restriction, now we can take the value of r is equal to what? R can be 0, yes. Then as r is an integer, do you have any integer between this range 0 and 2? Yes, we have one. Yes, we have one is integer. And can we take the value of r to be 2? No, we cannot take, because r is always less than the value of b, which is 2, right? So for this case, we will get only 2 values of r. Okay, so now considering this, so can we write the expression for a? Yes, we can write. For r is equal to 0, for r is equal to 0, what is the value of a? The value of a is 2q plus 0. The value of r is 0, right? So 2q plus 0, which is nothing but 2q. A is equal to 2q. Okay, now as per question, we need to show that the difference between a number and its square, that is, that if we consider a to be that number, then the difference between the a square and a is an even number. That is to show that a square minus a is an even number, right? So even number means you can express it as as we have considered q to be here, so we will consider now this q to be for even number case. Let's we have to show this expression, right? So we have cleared our aim here, that what we need to prove now. So let us consider that at first the LHS. Okay, what is the LHS? A square minus a. Okay, so do you have the value of a? Yes, the value of a is 2q, so we will substitute the value of a here. A square minus, what is the value of a? 2q. So we have done nothing but we have just substituted the value of a in this expression, okay, which was the LHS. We need to prove this is equal to this. Okay, so we have just substituted the value of a in both the values of a. Then if you do this, if you simplify it more, then 2 square is 4q square minus 2q, right? So you got this expression. Now can you take take anything common from these two terms? Yes, we can take, right? We can take 2 common from these two terms. If you take 2 common from these two terms, then what you will be left out with within the bracket, it is 2 into 2q square. Just multiply it, you will get the same result. 2 into 2 is 4. 4 into q square, it is 4q square, right? We are correct. So and here you are left out with only q, right? 2 into q is 2q. So this is the required term. Okay, so substituting the value of a, which is equal to 2q in this term, we got at last this expression. Okay, so now you can notice that here 2 is an integer, q we have considered it to be an integer, right? So we can say that the overall whole term is an integer, right? So we can replace it by any other integer. Let's say that integer be k. Okay, where k is equal to 2q square minus q. Okay, which belongs to an integer z. Z. Okay, for q belongs to z. For q belongs to an integer. For q belongs to an integer, we know 2 is an integer. So if q is an integer, so q square will also be an integer, and if you subtract whole term by again another integer, this will also be an integer. So we can replace this 2q square minus q by an integer which is k. Okay, so now we can see that we have expressed a square, the square of a number, the difference between the square of a number and this number, as 2k. So if you can express any number as 2q or 2k, okay, 2 is multiplied with any integer, so if you can express any number as 2 multiplied by some any other integer, then that is an even number, right? So the difference between in the square of a number and by itself, the difference between the square of a number and that number is an even number, okay. So as we can express it in the form of 2 into multiplied by some integer, okay. So now we will consider the value of r to be 1. So we have proved this statement is true for r is equal to 0. Now we will consider r is equal to 1. So if you consider r is equal to 1, the expression for a was a is equal to 2q plus r. Yes, so we have just substituted the value of r here. If you substitute the value of r is equal to 1 here, you will get 2q plus 1, right? 2q plus 1. So this is the required expression. So now according to question, what was the condition we need to prove? It was the square, the difference between that number and its square, right? So that is the square of a number and itself. The difference between the square of a number and itself is an even number. We need to prove that, right? So we just carry out this expression. We will just put the value of a in this expression, and we will see whether we will obtain an even number or not. Okay, so just carry out the further procedure by substituting the value of a in this expression. If you substitute the value of a here, you will get 2q plus 1 whole square, right? And this q is 2q plus 1. Okay, so you will get this. I guess you all know the formula of a plus b whole square. What was the formula? A plus b whole square is equal to a square plus b square plus 2ab, right? So you will just expand this in that formula. So it is a square, that is 2q square, plus b square. What is the term b here? It's 1 square, right? Plus 2ab, 2 into ab. What is a? 2q. B, what is b? It is 1, right? A square plus b square plus 2ab. We have expanded, okay. So minus, it is 2q plus 1. We will keep it like this for some time, and then we will expand. So what you will get from this further solving it, you will get 2q square is 4q square, right? 2q whole square is 4q square, plus 1 plus 2 into 2q into 1, it is 2 into 2 is 4 into q, 4q into 1, it is 4q, right? This is 4q, okay. Now keep this term like this, okay. Now you will get 4q square plus 1 plus 4q minus 2q minus plus, it's minus, right? Minus 1, okay. Now you will see that minus 1 and plus 1, it cancels out, and you will be left out with 4q square, 4q minus 2q, it's plus 2q, right? You are left out with this term. So now you can, I guess, take 2 common from these terms. It is 2q square plus then q. If you again multiply 2 in with both this term, you will get the same result. Just multiply it for verification. 2 into 2 is 4q square plus 2 into q is 2q, right? So you will get the same term. So we have just taken out the 2 common. As we now know that q is an integer, 2 is an integer, as q is an integer, q square will also be an integer, and the whole sum will be also an integer. So you can replace this term by k, okay? You can replace this term by k, where you write down where k is equal to 2q square plus 2. It belongs to an integer. It belongs to an integer. For write down q must be an integer, right? For q to be an integer, this term will also be an integer, okay? So as now we can see that the difference between the square of the number and itself, we got the final expression as 2 into some integer. And as I have earlier said that for a number to be an even integer, you must express that number as 2 into some integer, 2 into multiplied by some integer. Yes, we have expressed it in this form, and yes, now we can say that yes, the difference between the square of a number and by itself is an even integer. Difference of a number and its square, hence the difference of a number and its square is always an even integer, okay. So I guess these 2 problems are clear to you, and if you have doubt, please drop it in the comment section, and we will from next class we will continue with a new topic, okay. So till then, study well.